In this video, I'll show you how to draw raindrops on fruit and windows, and specifically how to shade a translucent sphere compared to an opaque one. And it's in my book, Ellen's Guide to Rhythm and Motion, on Amazon. To understand raindrops, I want to show you the difference between an opaque matte ball, a translucent shiny ball, and a glass sphere. So for the matte ball, we have a terminator that divides the light area that receives light from the shaded area that's turned away from the light. And you can draw a tangent light ray from the tip of the terminator down to the end of the shadow. And if you follow that light ray up, you will find that the sun is in the upper right. A translucent shiny ball is the secret to drawing raindrops or grapes. And let's start with the highlight, which looks like rectangular shapes. And they're from overhead lights, ceiling lights that are also rectangular. And the light travels straight through to the bottom and then to the surface where it reflects to our eye. Now notice in the opaque ball, the part next to the light is the lightest while the other side is the darkest. But with a translucent shiny ball, the part near the light is actually the darkest and the lightest is at the bottom. Now, this ball also casts a shadow. Its edges and its bottom blocks light to cast a shadow. And if you have a light area inside a shadow, as we do here, that tells the viewer that this is a translucent ball. Now, what about this glass sphere? Well, because it's a see-through glass object, it serves as a convex lens, so it flips the image both horizontally and vertically. You can see that the ground is on the top and the sky is on the bottom. But also, these trees are on this side of the ball and these trees are on this side of the ball. If you see a tiny raindrop on a leaf, you will see tiny upside-down reflections of the sky at the bottom of the drop. This shows you the details of the translucent ball, and I've diagrammed the different parts of it here. So the light is coming in this direction, and it's the opposite rule where the dark side faces the light, whereas the light side over here is away from the light. And that's opposite to what you see in an opaque sphere. Now the highlight is this little tiny dot, and it's on the dark side, so it tells us that the surface is wet and shiny. The light goes through the raindrop and then lands back here and sends light to our eyes, so this little area looks light to us. And then we see the shadow cast by the sides that go around this light area. Because the drop is a convex lens, it magnifies the texture underneath. And this magnification tells us that the drop is thick and tall. A flat, thin smear of water wouldn't magnify as much as this one. A raindrop combines gravity and surface tension to make the drop look like it's just about to fall. And this is the penultimate moment, right before the drop is about to fall. And to make it look convincing, you have to indicate that the drop is bottom heavy. And you can do that in two ways. First of all, narrow the top and make the bottom larger and bulbous. And the other way is to make it light on top and dark on the bottom, so it looks physically heavy. On a vertical surface, the drop begins to elongate. And if you want to suggest that it's moving down the blade, you again want it to look bottom heavy. So you want the bottom to be round and fat and the top being flatter and tapered like a tail. We can also see raindrops attached to various depressions like these veins. And when it spills over, you see these convex curves. So this is what we want to do. We want to draw drops on an apple. So here I have a photo and I've broken it down into its component parts. So the yellow part are the highlights where the light just hits the drop and then comes to our eye. Then we have the shadow on the bottom that seats the drop on the surface so it doesn't look like it's floating. And then the striking part is this very red area that's redder than the apple. And that's because the light goes through this drop, hits the apple skin, and becomes much more saturated and vibrant when it comes to our eye. These are raindrops on a window, and you can see that the light area reflecting the sky is below the dark area reflecting the land. But what's interesting is that if you look at the horizon, you can see that the dots on the horizon are half dark and half light. If we go down a bit, we can find these drops that are 2/3 dark and 1/3 light. And if we go up the same distance, we can find these drops that are 1/3 dark and 2/3 light. So basically, they start half and half at the horizon, and then you get more light areas as you go up, and you get more dark areas as you go down. These drops are reflecting an upside-down version of a fence with the sky above it over here. And you can see in all cases we have the fence on top and the sky below. And they're distorted by the shape of the drop. And here again the drop mimics what's around it, but upside down. So the ground is on the top and the sky is on the bottom. So check out my book on Amazon and please remember to subscribe.